Assalamualaikum and a very good day to everyone. My name is Shahira Adnan from UiTM List. I will be presenting my final year project entitled Application of Sonication and Microwave in Solvent Extraction for the Treatment of Oxidized Coal under supervision Dr. Siti Nolia Ali. This is my presentation outline. Introduction. What is coal? Coal is a solid fuel which forms from the remains of land plants after a long period of hardening and compression. Coal consists of carbon, hydrogen, oxygen, nitrogen, sulfur, and trace amounts of other elements. The characteristics of a high-quality coal are high carbon content and low oxygen content. Next, oxidized coal. Coal oxidation or oxidized coal occurs when a coal is exposed to oxygen in the air for a long period. As oxygen content keeps increasing, it will lead to the degradation of coal quality in terms of its chemical bonding, molecular weight and surfaces, coking properties and calorific value. Hence, these poor quality coals need to be treated by using suitable treatments. Oxidized coal happens when there is improper storage of coal during mining that allows the interaction of coal and oxygen. Thus, coals with these undesirable properties will deteriorate its quality. Coals are considered as the critical elements which becomes expensive and scarce due to their unstable demand for various aspects and applications. Therefore, coal should be recycled effectively as they play a significant role in supplying the energy to fulfill the economic demand. Next, it is important to develop an efficient method to restore the properties of oxidized coal. Moreover, knowledge on the properties and treatment of oxidized coal also need to be well understood. The objective of this study are first, to review on the properties of oxidized coal and the effect of oxidation towards the coal usage. Second, to review on the applications of solvent extraction with the aid of sonication and microwave for the treatment of oxidized coal. Moving to the literature review, which consists of two main parts, which are properties and effect of oxidized coal and treatments of oxidized coal. Properties of oxidized coal. Oxidation causes the formation of an extremely high cross-linking macromolecular structure in coals, along with poor melting and heating condition during the heating process. Therefore, hydrophobicity of coals will be decreased. When this happens, flotation behavior of coals will be affected and leads to a low heating value, which also known as net calorific value. Effect of oxidized coal are limited usage of coals and cannot be kept for a long period due to the degradation of its properties. Next is the treatments for oxidized coal. This review only focusing on the method of solvent extraction with the aid of sonication and microwave. In solvent extraction, the principle is like dissolved light. Polar solvents are used to extract polar components, while non-polar solvents are used to extract non-polar components inside the coal. Previous study by Sharma and Dhawan emphasized that pyridine is the most effective solvent for high-rank coal. As a result, sulfur, toxic metals and harmful constituents such as vanadium and mercury were successfully extracted out. Rahman et al. 2017 investigated that N-methylpyrrolidone has been proven as a powerful solvent for extraction of bituminous coals as it has a high capability in dissolving to the highest extent and gives a higher extraction yield. The researchers also emphasized that N-methylpyrrolidone yield is more efficient than other solvents such as dimethyl sulfoxide, ethylene diamine, and pyridine. In total, coals were upgraded by solvent treatment and resulted to the removal of sulfur, mercury, and moisture content. In another work, Muatang-on et al. 2017 utilized kerosene and 1-methanephthalene as solvent for extraction of coals. Kerosene was found to be the efficient solvent for extraction of two low-rank coals, Loy Yang and Pendupo, as it has low boiling point, thus more effective to be separated and recovered from the product that had been upgraded. Overall results presented that low-rank coals were upgraded by removing the oxygen in the form of either water or carbon dioxide during the treatment. Lastly, Solmes et al. 2016 investigated on utilization of N-methylpyrrolidone, quinolone, and 1-methanephthalene in the extraction of bituminous and lignite coals. The researchers emphasized that extraction of both types of coal using N-methylpyrrolidone way more effective rather than quinolone and 1-methanephthalene as it destroyed the pi-pi interactions and charge transfer interactions between aromatic groups in coal, hence producing the greater yield production. The treatment proposed resulted to the properties of coals with high thermoplastic properties, calorific value, thermal reactivity, and slightly ash production. In sonication, ultrasound is being utilized in order to agitate the nanoparticle inside the polymer matrix. The waves transmitted resulting to an oscillation in the direction of the wave, thus producing longitudinal wave. The temperatures and pressures used to sonicate is approximately equal to 5000 Kelvin and 500 atmosphere respectively, followed by vast heating and cooling rates about 1010 Kelvin per second. Previous study by Chanela et al. 2018, Indian bituminous coal were categorized as A and B. As a result of sonication, A resulted to 4.68% of oxygen, meanwhile B extracted 6.68% of oxygen with the aid of N-methylpyrrolidone as main solvent and 1-methylnaphthalene or ethylene diamine as the co-solvent. In addition, a study conducted by Z et al. 2017 claimed that the samples of anthracite oxidized coal extracted out 29.24% of oxygen due to the treatment of sonication. The crushing effect which exerted on oxidized coal due to ultrasonic cavitation, resulting in the removal of oxidized layer. Hence, it leads to the increasing of carbon content and decreasing of oxygen content in oxidized coals. Lastly, Mesrogali et al. 2016 investigated on extraction of low-rank tabasco and quinolone as the solvent. In total, 87.52% of total sulfur was successfully removed by using sonication method. Last treatment is microwave. Microwave requires an electromagnetic power composed of two oscillating perpendicular fields, which are electric field and magnetic field, with a frequency of 300 MHz to 300 GHz. The function of electromagnetic field of microwave are breaking down the interactions of van der Waals and hydrogen bonds, as well as instantly polarize the molecules existing inside the coal despite of dissociation, some of small fragments along with the solvent. Oxygenated compounds are able to be extracted out using dissimilar types of solvent. This is because when the oxidized coal exposed to the microwave, generation of micropores as well as the surface area and the volumes of pores will be increased. Hence, the solvent will be easily diffused into the coal matrix and able to extract out the undesirable compounds. Previous study by JV et al. 2020, microwave technique was employed to extract oxygen-containing substance from bituminous oxidized coal by using acetone as the solvent. The researchers found that microwave caused the particle present in the solvent to be energized due to the mechanical and thermal effect between coal and solvent. This study concluded that by using microwave, 53% of oxygenated compounds were successfully extracted out from the oxidized coal. In a research by Xiong et al. 2018, microwave method was used to extract oxygenated compounds, sulfur, alkenes and arenes from low-rank Namaho oxidized coal within less than 1 hour period by using tetrahydrofuran and cyclohexanone. The researchers found that cyclohexanone are more effective compared to tetrahydrofuran in extracting oxygenated compounds. This is due to the potential of cyclohexanone in penetrating into the macromolecular structure of coal and its synergetic effect with the microwave energy. Chanela et al. 2018 investigated on microwave method by using Indian bituminous coals and solvent ethylene diamine or mixture of N-methylpyrrolidone and ethylene diamine. As a result, oxygenated compound in coals were extracted out and produced a high percent of yield. Lastly, based on research by Chen et al. 2015, microwave-assisted technique have been used to treat subbituminous shameful oxidized coal by using tetrahydrofuran as the extraction solvent. The researchers stated that microwave developed a good efficiency in terms of extraction as it is able to penetrate deep into the molecular structures of oxidized coal within a short period of time. Conclusions and recommendations. In conclusion, oxidized coal happen due to exposure of oxygen for a period of time, and when coal allows the presence of oxygen, the degradation of coal quality and development occurs. The uptake of oxygen by coal resulting to the change in its property, such as its mass, surface, and the chemical bonding between carbon, oxygen, hydrogen, and other elements existing inside the coal. The effect of oxidized coal with undesirable properties lead to a limited usage of coal. Thus, they cannot be kept for a long period. In order to fulfill the coal demands, oxidized coal must be treated. In this review, method of solvent extraction with the aid of sonication and microwave was studied as a means of treatment of the oxidized coal. In sonication, the nanoparticle inside the macromolecular structure of coal is being agitated by the ultrasound wave. Microwave penetrated into the coal matrix by utilizing electromagnetic power to break down the interactions of hydrogen bonds and van der Waals. Overall, between these two methods, microwave method is more efficient to reduce the oxygenated compounds from the oxidized coal due to its ability to penetrate into the body of coal is deeper compared to sonication. It is recommended to investigate on other treatment methods for oxidized coal, as there are additional avenues for research that can be developed by using methods other than sonication and microwave in solvent extraction for the treatment of oxidized coal. That is all from me. Thank you and have a nice day, everyone.